Recording started.
Okay, so you can see a picture of this cowboy guy here. I don't know if you guys have ever heard of this guy. His name was John Wayne. But maybe your parents have heard of him before. If you ever watch old westerns, you'll see this guy on there. And he was a famous cowboy actor in the States. And so I'm just talking here about how people change their names sometimes. This guy's original name was Marion Wayne. And I guess he figured that John Wayne would be a better name for a cowboy. So he changed his name. And I got another picture of another guy here. I don't know if you ever heard of this guy. You've probably never heard of the name Eric Weiss before. He was an amazing escape artist. You could put this guy in handcuffs. You could put him in anything, and he could get out of there in, like, you know, sometimes a minute or less. But you probably heard of the name Harry Houdini. All right, so this is all just to kind of bring out the point that sometimes people change their names, and sometimes we have to rename fractions too. And when we rename fractions, all we really do is give them a different denominator, right? And the way we do that is either multiply or divide both the top and the bottom of the fraction by the same number. So when we rename a fraction, it still equals the same amount, but it just it's just put in a different form, right? Okay, and you guys are probably also familiar with putting a fraction in lowest terms. And when a fraction's in lowest terms, that means we can't divide any more number into both the top and bottom anymore. We've done all the dividing that we can. Okay, so that's just kind of clearing up a few things. And just notice a few people are writing there, so I'll just give you a chance. See what's up. Okay, everything's cool? Yeah, 1/2 is the same as 4/8. Good example there. So that's renaming a fraction. All right. So what we want to do in this case here, we can rename this in lowest terms, it says, right? It's got to be lowest terms. So what we need to do is find the largest number that divides into both the top and bottom. And this is what we call the greatest common factor with these two numbers, right? The way we can do that is by finding prime factors. We could do it that way if we want, and we're going to look at how to do it that way. But you don't have to do it that way. If you can ask yourself, what's the largest number that divides into both 8 and 24, then you can just use that number. Okay, but I'm just going to show you how to do it using prime factors. So let's check that out. Okay, so for 8 and 24, what we do to get the prime factors, you remember you can make these factor trees. So first of all, just find any two numbers that multiply to give you 8, and then break them down some more. So since we have 4 here, we can break that down to 2 times 2. And now we've got to all the prime factors, because we can't multiply any numbers to get any of these 2's, other than 1 times 2, and that doesn't count. Okay? So we found the prime factors for 8, that's 2 times 2 times 2. We do the same thing for 24. We break down all the numbers, and we get 2 times 2 times 2 times 3. And then we look at the numbers that are in common between 8 and 24. And we can see that 2 times 2 times 2 is in common for both numbers. So 2 times 2 times 2 is 8. So that tells us that 8 is the largest number that divides into both 8 and 24. Now again, you might have been able to figure that out just by looking at the two numbers. But if you can't, you can use this method with the factor trees. Okay, so once we've done that, then we can do the dividing. So we found that 8 divides into both of them. 8 divided by 8 is 1. 24 divided by 8 is 3. And that's as far as we can go. So that's the lowest terms for that fraction. Or sometimes we call it the least putting it in least terms. Okay, so that's how we do it. And we'll look at another one here. So we've got 21 and 35. Now when we had 8 and 24, we saw that 8 could divide into the other into the denominator that was in the fraction? Yeah, okay, so you think of pizza? Yeah, pizzas help a lot with fraction. They also make you hungry sometimes. Alright, so for this one here, we got to find what number divides into both 21 and 35. And again, you might be able to look at it and just figure it out. You always want the most of anyone in the family? I love pizza too. I like Pizza Hut. Anything with mushrooms, I would say tomatoes are good too. It's making me hungry. You guys like mushrooms, or you like pizza too? Sherry and Joel? Yeah, who doesn't like pizza, right? Hardly anybody. Okay, so we're going to look at 21 and 35 and find what number divides into 21 and 35. So if we look at 21, we can see that 3 times 7, we break it into 3 times 7. We can't break those numbers anymore, right? Same with 35. We break it into 5 times 7. We can't break those numbers anymore. But we see that both numbers have 7 in common. So 7 is the number that we're going to use here. So 7 is what we're going to divide into both top and bottom of the fraction. So if we go on to the next page, we can see that we're dividing 7. 21 divided by 7 is 3. 35 divided by 7 is 5. We can't go any farther. That's the lowest terms for the fraction. And we're done. So we've renamed it, right? Okay, I'll show you guys one more. So 81 and 36. So again, we'll use that method of breaking things down, right? So we're going to break down 81, and these are, again, the prime factors. Okay, so after we break down all the numbers until we can't find any numbers that multiply together to produce them, 81 is all these 3's multiplied together. When we break down 36, it's these numbers multiplied together, and we look at all the numbers we have in common, we have 2 3's. In other words, 3 times 3 appears for both of them. 3 times 3 is 9. So 9 is the largest number that will divide into both 81 and 36. And again, you might have been able to look at them and figure that out, but if not, give this a shot. Okay, so we're going to divide 9 into both 81 and 36. And here you can see that done. And we get 9 quarters. Okay, so similar situation for all of them, but this one was probably a little more challenging than some of the other ones, just had the number 81. Okay, now these guys here, if you're wondering, they're not related to me. And honestly, I have no clue who these people are. I just found their picture on the internet. The reason I found these guys is because I just typed in order of height into the internet, into Google, and it came up with this picture, among other pictures, right? And so, yeah, sometimes it's fun when you take a picture, just kind of put people in order of height. Kind of makes a cool picture. And so, same thing with pictures and fractions, right? So we do the same thing with fractions sometimes. So let's check out how we would order these 3 fractions in order from smallest to largest or greatest. Okay, so how are we going to do that? So guys, what do we need to do to the fractions so we can put them in order of height? Can anyone tell me? It's the same thing when we're adding or subtracting fractions. What do we always need for the fractions to be able to add them or subtract them? Okay, lowest common denominator, right? We need a common denominator. Something's got to be in common, then we can add them. Sorry, a fraction on the brain. It's kind of like the pizza thing, right? Because once they become a common denominator, we can just consider them like pizzas. And I'll show you what I mean in a sec. So, okay, so we find the common denominator. The way you can do it to find the common denominator is to find the least common multiple of each of these numbers. So what you do is you just say, okay, 5, 10, 15, 20, 25. In other words, you count by 5. So you do that for the 5s, you do that for the 9s, and you find what's the smallest number that both of them have, and that's 45. So what that means is we want to use 45 as the common denominator for these fractions. Okay, so we're going to first of all start with 3/5. We're going to change it into some fraction that has 45 on the bottom. So we start with 3/5. We say to ourselves, okay, what do I have to multiply 5 by to get 45? I have to multiply it by 9, right? Yeah. Okay, so I have to multiply the 5 by 9, so I have to multiply the top of the fraction by 9 as well. Always have to multiply the top and the bottom by the same number, right? Okay, so I get 27 over 45. Okay, so I've already changed the first fraction into 45. Let's check out the next one. Okay, so when we want to do 8/5, we're going to do the same thing, multiply by 9. But it's going to be a different situation. We should have the line here. When we have 4/9, we need to multiply 9 by 5 to get 45, right? So we multiply the top by the same amount. Okay, so now we've changed all those 3 fractions into some fraction that has 45 on the bottom. And because of that, we can put them in order. And again, when I was talking about pizzas, it's just kind of like, you know, if you look at a 45th as being like a pizza, it's like here we have 27 of them, here we have 72, here we have 20. Okay, so this is the smallest, second, and then that's the largest. Okay, so we just look back at our original fractions. This original fraction was changed into this one, and this one was changed into this one, and this one was changed into this one. So this is the order we would put for our answer. Okay, so the original order we had was different. This is the order that shows from smallest to largest, and we've kind of proved it right here because this one equals that equals that, and that equals that. Okay, so that's how you do that. And again, it's kind of a similar idea to when you're adding and subtracting fractions. Okay, so we know that we always need the lowest common denominator when we want to add or subtract fractions. And I'm just going to review with you guys two different ways you can find the lowest common denominator. Okay? So here's one example. You're adding together 3/7 and 5/14. Well, what you always want to check, if one denominator will divide into the other. So if 7 divides into 14, then you want to use 14 as your common denominator for both fractions. And you would change the 3/7 into something over 14. You know, you would multiply by 2 and by 2. You make that into 6 over 14, and then you can add it to 5 over 14. And again, it's kind of like 6 pizzas plus 5 pizzas is going to equal 11 over 14, 11/14, right? Okay? So always remember again that when you add fractions, you only add the top of the fraction together, right? You don't add the bottoms together, right? Okay, so that's one way you can do it. If the one denominator, sorry guys, I always forget to move the phone out of the room. Okay, so yeah, I'll just wait. Yeah, so if the 7 can divide into the 14, then we're going to use the 14 as our common denominator. So always check that, first of all, when you're trying to add or subtract fractions. Okay, let's look at a situation if it won't. So if a denominator won't divide into the other, we need to find the smallest number that both denominators will divide into. And we looked at this earlier, right? We look at the multiples of 4, and we see that it goes 4, 8, 12, 16. Yeah, it goes up to 20. We notice that both of them have 20 in common when we list their multiples. Okay, so that's the lowest common denominator. Okay, so that's what we want to use to add our two fractions. And so I'll just show you how we do it here. Oh, no, maybe I'm not. I'm just showing you two examples there. Okay, so that's two different ways we can find the denominator. And again, I'll just review. If one divides into the other, that's the first thing we check. Then we want to use that one. If neither one of them divides into each other like this, then we list the lowest common multiples and choose whichever one is going to be the first one that each of them have in common. Okay? So that's what we want to do to add and subtract fractions. Okay, so I just want to ask you guys a question. If we want to add these two fractions, what do we need to be able to add these two fractions? What's that thing called again? Okay, lowest common denominator. Good. And how are we going to find it here in this particular situation? How are we going to find the lowest common denominator? Which of those two methods are we going to use? Okay, that's all right. So which of the two methods that I just showed are we going to use here? That's right. We're going to use the one where the one denominator divides into the other. Good stuff. Okay, so we'll go to the next screen. 4 divides into 8. Okay, so we've pretty much gone through this stuff. So we're going to use 8 as our denominator and change 1/4 into something over 8. So we say, okay, what do we multiply 4 by to get 8? We multiply 4 by 2. So we multiply top and bottom by 2. We get 2/8. So now, instead of 3/8 plus 1/4, we have 3/8 plus 2/8. We add them together. Again, we're only adding numerators, right? 3 plus 2 is 5, and the 8s all stay the same. Because again, it's like 3 pizzas plus 2 pizzas equals 5 pizzas. Because the 8th is just like a pizza. Today is a pizza theme, I think. Okay, but maybe it's not, because now we got bagels. Any of you guys like bagels? Uh-huh. You guys like cream cheese, or what kind of stuff on your bagels? Cream cheese is good, eh? Do you like it straight, or do you like it with like a flavor? Peanut butter and chocolate, ooh. Yeah, there's not too much that peanut butter and chocolate goes bad with. I love Reese's peanut butter cups, those are awesome. Do you seriously have it with peanut butter and chocolate, Logan? Yeah, those are just great. And sometimes my daughter buys me one. She goes to the store and gets me one. What a sweetheart. Okay, so we got a question here. And this one says, Marion has 2/3. You'd eat Reese for his name, hey? Yeah, no doubt. So Marion has 2/3 of a bag of bagels. She finds another 1/4 of a bag of bagels and puts these in the first bag. What fraction of the first bag is now full of bagels? So what do you guys think? What kind of math operation do we need to solve this problem? And when I mean math operation, I mean, is it adding, subtracting, multiplying, or dividing? That's right, we're going to add, because we want to add the fraction of bagels we have in the beginning and add the other fraction, and then we'll know how full that first bag is. Good stuff. Okay, so we add those two fractions, 2/3 and 1/4. Again, we're doing the same thing we did before. In this situation, 3 doesn't divide into 4, or vice versa. So we know that they both divide into 12. Now we could have got that by going, 3, 6, 9, 12. And then with the 4s, we would go 4, 8, 12. We could have done it that way. But, because they're small numbers, 3 and 4, you might just kind of recognize it as well. Okay? So again, we're doing the same thing. We need to multiply 3 by 4 to get 12. Okay, good. And so in this situation, we're multiplying top and bottom by 3. So we get 8/12 plus 3/12. And we're going to add them together to get 11/12. So the first bag is now 11/12 full of bagels. Indeed, calculators are very good. Okay, let's check out the next one. So now we're going to subtract a fraction. Almost the same thing as before, right? Very little difference from before. Okay, so all we need to do is change this 2/3 into something over 12, because 3 divides into 12. Okay, so we need to multiply the 3 by 4 to get 12. Same with the top. We get 8/12. So now we have 11/12 minus 8/12. See it here? We get 3/12. If the question said, put it in lowest terms, then we couldn't keep it at 3/12, right? We need to find the largest number that divides into both top and bottom, so that's going to be 1/4. Or, sorry, I should say that's going to be 3. But when we divide 3 into top and bottom, we get 1/4. All right. Cool. So we got another one here, and this is just another subtracting situation. And again, in this one, we got to find the common denominator using the multiple method, because we can't divide one into another. So we do it for 4. We get these numbers. We do it for 5. And again, we can see that it's 20. It's the lowest common multiple. That's going to be our lowest common denominator. And again, you guys know the routine with this here. Multiply top and bottom by the same amount. So you end up with 16/15 minus 15/15, so you get, or sorry, I should say 16/20 minus 15/20, and you get 1/20. Okay? So now we'll go into something that's a bit of a word problem here. So now, I don't know if you guys, whoa, okay, who was that? All right. That's all right. Do you guys remember these questions from the homework? Because these are right from the homework. Okay, good stuff. Now, have any of you guys ever been to Nunavut before? How about the Northwest Territories? You ever been up there? Nunavut is like the part of, it used to be the Northwest Territories was all just above Canada, like, you know, the section that we call the Northwest Territories above Alberta, but that part also stretched over to eastern Canada, like Ontario and Quebec. But now they call the part above, you know, Ontario and Quebec. I can't remember where it starts exactly, but they call that Nunavut. Yeah, I actually went on a missions trip. I went about, I don't know, maybe 7 years ago to Northwest Territories. So I didn't go to Nunavut, but it was pretty freaky because I was helping to do the pastor's roof, and I was working on it until 5 in the morning. So it's like 5 in the morning and it's totally bright out. And, you know, people would come and knock on his door, and I went for a walk with these people, and you walk around downtown. Like, it's not a very big place, Fort Good Hope where I went, but you see people walking around, you know, at 3 in the morning, just bright daylight. It's kind of different to see. So, yeah, if you guys ever get a chance to go to one of those places, it's pretty cool. I remember when I first came to Alberta, when I lived in Ontario, I thought like northern Ontario was pretty far north, but Edmonton is way farther north than northern Ontario, where I used to call northern Ontario. So we actually do live pretty far north up here, but it's good province. I love to live here. I love being close to the mountains. Anyways, getting off track. So we're talking about Nunavut here, and so Nunavut covers about 1/5 of Canada. So the whole amount of area in all, if you divide it up, Nunavut is about 1/5 of it, and Manitoba is only 1/15. Okay, so the question here is, what fraction describes how much more of Canada is covered by Nunavut than by Manitoba? So what math operation do you think we're going to solve this problem with? We're trying to find how much more of Canada is covered by Nunavut than Manitoba. You're going to add, subtract, multiply, or divide. That's right, we're going to subtract. It's like if you said, you know, how much bigger is 11 than 9? You would have to subtract 11 minus 9 to get 2. And so it's kind of the same deal. You know, when you're talking about how much more something is than something else, you have to subtract. Good. So in order to get that amount, we're going to subtract 1/5, which is the amount of area for Nunavut, minus the 1/15 for Manitoba. And so how are we going to do that? Well, that's basic, you know, subtracting of fractions like we saw before, right? Okay, so I'm just kind of writing down the question here. So what math operation do we do? We're going to subtract Nunavut's area minus Manitoba's area. In other words, 1/5 minus 1/15. How are we going to do that? Same deal as before. We find the lowest common denominator. And how are we going to find it? Well, we're just going to divide 5 into 15. So we're going to use 15, right? Okay, so that's just kind of setting up the problem. And then actually doing the math is, again, we're just multiplying 5 by 3. So we multiply top and bottom by 3. So now we've got the 1/5 is 3/15. So now the actual math we're going to do is 3/15 minus 1/15, and we get 2/15. So again, whenever you have a word problem, remember always to write a sentence at the end that kind of answers the question with the actual number in it. So instead of just writing 2/15, say there's 2/15 more land is covered by Nunavut than Manitoba. All right. So here's one. This is kind of a different question, kind of a funky question here. It says, estimate whether each sum, remember sum is adding two things together, right? Whether each sum is greater than 1. Explain your estimate. So what do you guys think? How would you figure out, if you're estimating but not doing the math, how would you estimate whether 2/3 plus 5/7 was, you know, less than 1 or greater than 1? Okay, Logan, you said 3 is, you mean 2/3 is big? More than, is that what you mean? It's more than half? Kind of the same idea Sherry is saying? That 2/3 is more than half. Okay, so 2/3 is more than half. And how about 5/7? Yeah, 5/7 has got to be more than half too. And I'll kind of show you why that is right here. So that's what I wrote down. Think of whether each fraction is greater than 1/2 or less than, I should have said greater than 1/2 or less than 1/2. Okay, so 2/3 is greater than 1/2, so is 5/7. And I'm kind of proving it right here because when you look at 2/3, okay, you're saying you get about 11/5. One and 1/5. Okay, so yeah, like when you look at the number 2/3, if you didn't recognize whether that was over half, you could change it into 4/6, and then you would definitely recognize it because you know 3/6 is 1/2, and 4/6 is a little bit more. Same with 5/7. If you didn't recognize it, like if it was a trickier fraction than that, you could change it into 14, and you would know that 7/14 is half, so 10/14 is, you know, is going to be greater than 1/2. But you know, even the fact that you know that half of 7 is 3.5, so you know that 5 is larger than that. You know it's going to be larger than a half, right? Okay, so you guys have got it. You know, because both those fractions are greater than 1 when you add them together, the sum of them is going to be greater than 1. Okay? All right, let's look at another one. Now this one is a little bit different. So let's see if you can think of an idea for this one. So this one here, I don't think you guys will be able to figure this one out the same way you did the last one. So see if you can come up with a way of solving this one that's a little bit different than the last one. So so is the sum of 5/6 plus 1/7 greater than 1 or less than 1? Okay, smaller than 1? Okay, so why would it be smaller than 1? Okay, 1/7 is less than 1/6. All right, and I'll show you right here what it's exactly the way I was thinking of it. Because if it was 5/6 plus 1/6, then you would get 6/6 or 1, right? But we know that 1/7 has got to be less than 1/6, so therefore the answer's got to be less than 1, because 1/7 is a smaller fraction than 1/6. Okay, good stuff. You guys are onto this stuff. All right, hey, there you go. There you go. Perfect. Thumbs up. But what I'm showing here is a project. I just found this. You would eat the 6, eh? Okay. You're talking because you still got pizzas on the mind, right? I don't know what this is here. This could be pizza, but no, it doesn't look like it. But this guy here is doing a science project, right? Have you guys ever done a cool project that you really liked? Maybe a science project, or maybe can you ever think of a project you really liked a lot? Yeah? Anybody want to tell about a project they did? Oh yeah, those adding together Coke and Mentos is awesome. If you ever look on the internet and look up Coke and Mentos, you'll see some pretty cool stuff. So taking a hammer to carve plastic, break in one shot. Metal don't break by car. Oh, plastic. Okay, sorry. So are you saying Logan, this was like an old car, or were you fixing the car? A toy car, okay. I have a friend that, two friends actually, they took an old car of my friend's and they went out and did a commercial where the guy was just beating up the car. Like, I can't remember how the commercial worked, but it was pretty funny actually. He just kept chucking things at the car and stuff. And another thing that happened in cars once is a friend of mine, well, there was about 4 of us or 5 of us in all. We each took $20. Each team took $20. We drove to the edge of Edmonton, and we bought a bunch of food, and we had a food fight in cars. So the windows were open, and we're like throwing stuff through the windows. The car's covered in plastic, but again, it was like a beater car. Both cars were beater cars, and we just had an awesome time. We did things like we had pita shells filled with mustard and chocolate, and that was one thing I remember hit me in the face. And what I did to get the other guys, I got some shortening, and I rubbed shortening on their windshield, and they were stuck for a good while trying to clean off that shortening. So it was a really good time. We got a video of the whole thing. So anyways, this is all just kind of to introduce the topic of projects, okay? Because the next question is all about projects. So, okay, so we got this guy here, Kyle, and Kyle has 3 hours to complete his project in all. Now he thinks that he's going to need about 1 5/6 hours to design and build. How much time will he have to write the report for his project? Okay, so what do you guys think? What math operation are we going to use for this one? Okay, we're going to have to use minus. Good. All right, and what numbers are we going to need to change to be able to do the math? Like, how are we going to do the math? How are we going to be able to? Can we do the subtracting the way the numbers look right now, or do we have to do something to them? Okay, well, we will have to do something because we've got fractions here, right? We've got a whole number and a fraction, and we've got a whole number. So we're going to have to change them somehow. And I'll show you how, okay? So let's check it out. Go to the next screen. What we want to do, okay, so we're going to do subtracting, like you guys said. And so total project time minus the time to design and build equals time to write report. Okay, so here's the subtracting we do. And so we're going to need to change both fractions into sixths. Okay? So in order to subtract a whole number by, or a mixed number from a whole number, we're going to have to change this 3 into 6. And then both numbers will have a fraction that's 6. Okay, so how we do that, the number 3, to get it into 6, 1 and 1 6, you thinking that's going to be the final answer? Okay, well let's check it out. So in order to take the whole number 3 into 6, the number 1 equals 6 over 6, right? Because any number where you got the same number on top and bottom equals 1, right? And 6 over 6 is like if you have 1 pizza divided into 6 pieces, it's still 1 pizza, right? Okay, so if we want to take the number 1, or sorry, if we want to take the number 3 and find out what fraction it is, we take 6 over 6 and we multiply it by 3, right? And so we get 6 times 3 is 18, 6 times 1 is 6, so 18 over 6 is 3, like Logan said. All right, so we've changed 3 into 18 over 6, and now we need to change this number into an improper fraction. We can't subtract 18 over 6 minus 1 and 5/6, can we? So we're going to have to make it so that this is just one big number on top of the 6. Then we can do the subtraction. So the way we do that again is, you guys remember when we're trying to change an improper fraction, we multiply the 1 by the 6, and we get 6, and then we add the top number. So multiply and then add the top number. 1 times 6 is 6, plus 5 is 11. So this fraction is going to equal 11 over 6. So we're going to subtract 18 over 6 minus 11 over 6. So we'll do that here. And so when we do that, we're going to get 7 over 6, and like Logan told us, that's the same thing, right? 7 over 6 is the same thing as 1 and 1 6. So Logan must have done this ahead. You win. Good stuff. Right on. So we are going to write at the end, again, you write a statement, like you said, so Kyle took 7/6 or 1 and 1 6 hours to complete his project. Good stuff. Okay, so now we got this guy named Luke, and he's taken his day, and he's figured out how to divide up his day. All right, so let's check out his day. What does he do? Okay, well, you can see most of his time is spent sleeping. Well, I shouldn't say most of his time. The biggest fraction out of all the fractions. That wouldn't be good if he spent most of his time sleeping, right? And then second, school. Well, school and other. And then a couple other things too. So the question we have here, what fraction of the day does Luke not spend sleeping or in school? So how do you think we'd figure this question out? What fraction of the day does he not spend sleeping or in school? Any ideas? Okay, well, if we think about the picture here, the amount of time he not spends sleeping in school is this amount here. Okay, that amount plus that amount, okay, is the amount he spends not sleeping in school. Okay, so can you think of something we can do with math to take away this amount and then be left with this amount here? Any idea? Okay, well, the first thing is, if you think about his whole day, right, we got to think about, we take his whole day and we've got to make it into some sort of fraction, right, at some point. But we take his whole day, that's this amount here. If we take the whole day and then we take away these two fractions, the fraction for school and the fraction for sleep, would you agree that we're then left with this amount here, the red, purple, and yellow, which added together equals the fraction of the day he does not spend sleeping or in school? Does that make sense? Okay, so we want to do some subtracting, and here's how it works then. Go to the next screen. So 1 equals, like the whole number 1, that's his whole day, right? And if we take away the number 1/4, that was the amount, what was that again? Which amount was 1/4? That was the amount in school. And if we take away the amount in sleep, the amount we're left with after saying 1 minus 1/4 minus 1/3, that's going to be the rest of his day. Okay, so this is the math we have to do, 1 minus 1/4 minus 1/3. Okay, so next question is, what common denominator are we going to use? What do you guys think? Okay, we could use 24. That's one possibility. Can you think of another one if we were thinking like the lowest common denominator, what we would use? That one would definitely be good. You know, we could do the math that way. We could also use 12, right? Since both 4 and 3 divide into 12. Okay, so again, we can use either 24 or 12. So let's just say we'll use 12. So what we need to do then, here's the math. 1 minus 1/4 minus 1/3. So first of all, we're going to change the number 1. Again, that's a whole number. To change it into a fraction with 12 on the bottom, it's just 12 over 12, right? That one's too easy, right? And then the other ones, I won't go into that in too much because you guys know this by now. Okay, so we change 1/4 into 3/12, doing it this way. Same with 1/3. We do it this way, into 4/12. So then we do the math. It's going to be 1 minus 3/12 minus 4/12. Okay, so here's how it pans out then. You get 12/12, that was the 1, minus the 3/12 minus the 4/12. So 12 minus 3 is 9, minus 4 is 5. So the answer is going to be 5/12. So 5/12 of his day is spent not sleeping or in school. Okay, so does that kind of make sense how we did that? Right on. Okay, so now we got a situation where we got two mixed numbers being added. There's a couple different ways you could do this. You could change each one of these into, well, I was going to ask you guys first of all, but Okay, yeah, why don't I ask you first of all, how would you do this if you were going to solve it? Because we might get some different answers here. Okay, well, you could either make this into a improper fraction, so like multiply 2 times 4, which gives you 8, add the 11, that gives you, or add the 3, that gives you 11, so there's going to be 11 over 4, add that fraction to this one that we're going to make into an improper fraction, then you could change the denominators. You could do it that way. I think when you're adding fractions, a lot of times it's most simple to just add whole number to whole number, and then add fraction to fraction. Okay? That's when you're adding mixed numbers. If you were subtracting mixed numbers, I wouldn't do it that way because it gets a lot more difficult. But for adding, I think that's probably the best way to do it. So add whole number to whole number and fraction to fraction. So if we add whole number to whole number, 2 plus 3 equals 5. So that part's taken care of. Now all we need to add together is 3/4 plus 8/9. Okay, so if we're going to add that together, we've got to find a common denominator for 4 and 9. So again, we're going to do that least common multiples thing where we just write them all out. We find out where it's in common. You guys can see that 36 is in common for both of them, right? So that's what we're going to use to add our fractions. So we add those two fractions together, we get 59 over 36. Okay, so that's the answer we get from adding together these two fractions, 59 over 36. Okay, so we already added together the 2 and the 3. That gave us 5. We get 5 and 59 over 36. Now, most of the time, that wouldn't be the best math answer. Can anybody tell me why that's not really a good math answer? 5 and 59 over 36? It has to do with the fraction. What's the problem with the fraction there? Yeah, it can be reduced, and because normally we don't like fractions that are greater than 1. So what we want to do is we want to make this into, we want to find out what 1 is, and we know that that's going to be 36 over 36, and then we're going to add that 1, that whole number we produced from the fraction 36 over 36, we add that to the 5 to get 6, then we find out what's left over. And so to find out what's left over, we subtract 59 minus 36, and that gives us 23. Okay, so that's going to be our final answer, 6 and 23 over 36. Okay? So you can always assume that you don't want to have a fraction that looks like this, 59 over 36, because you always want to make it into a 1, another 1. Take another 1 out of this fraction and add it to the 5, and you get 6. Okay? So does that make sense how you do that there? Okay, so I think we're almost done. The next one here is, this one's actually going to be kind of similar to one we did already. So I want to see if you guys remember how to do this one. So how are we going to do this math? Can anyone tell us? We've got the whole number 4 minus the mixed number 2 and 3/7. Okay, so again, whenever we add or subtract fractions, what do we always need? Okay, so we're gonna subtract. Okay, we always need the lowest common denominator. So somehow we're gonna need to make both the 4. Oh. Hey Natalie, how's it going? That's good. You're just catching us right at the very tail here. We're almost done. But hey, I'm glad you could join us. How's things going in your neck of the woods? Right on. So anybody have any snow where they live right now? I don't think there's any in Alberta right now, but or maybe in the mountains or something, could be. Yeah, it's seems like it's a little warmer this year because a lot of times by this time of the year there's snow on the ground, I find. So, but hey, if you really like skiing and snowboarding and stuff like that, yeah, I live in Edmonton. That's right. You as well, right, Logan? You're on the west side, eh? Yeah, I'm not ready for it either. I like on the west side where Logan lives, Candy Cane Lane. That's a pretty cool place. Do you live anywhere near around there, Logan? I don't know if the rest of you guys have heard of that. They just got a boot. The houses on that area are just really done up around Christmas time. It looks awesome. Oh, you live in the south. Okay. Why did I think you were on the west side? Maybe that was the La Valleys, I think, and they just moved. Well, you just moved as well, Logan, didn't you? Anyways, yeah. Do you know about that, Sherry? Okay. Yeah, if you're ever around Edmonton at Christmas time, it's really cool. It's on the west side. I think it's around 149th Street or something. But I can't remember what avenue. But you could find it pretty easy looking on the internet. So, okay, so guys, let's do this one here. So whenever we do any kind of subtracting of fractions, we always need a lowest common denominator, right? Oh yeah, it used to be on the west side. Yeah. Okay, so guys, we need a lowest common denominator. Do you guys know what denominator, we're going to use to subtract 4 minus 2 3/7? What number do you think is going to be on the bottom of the fraction? Yeah, that's right. It's going to be 7, right? So we need to make the number 4 into something over 7. Can you guys remember how to make the number 4 into something over 7? Okay, that's right. Like Logan said, it's going to be 7 over 7. Every time you get 7 over 7, that equals 1, right? And I'll just show this here. Earlier we were talking about pizza and stuff. Now if I divide this into 7 parts, yep, there's the pizza. I don't think it's going to be very easy for me to do. I think if Logan had a chance to eat this pizza, I know which ones he would go for. Okay, how many we got so far? We got 4, 5, 6, 7. Okay. So, you can see that 7 sevens equals 1, right? It's just one piece of pizza divided into 7 parts. So that's where you look at the fraction Logan wrote, which is 7 over 7. That just stands for the number 1, right? If we want to get the number 4, we need to multiply 4 by 7 over 7. And so all we need to do is multiply the top of it, and that's going to give us 28 over 1. Okay? So does that make sense, Logan? It's going to be the 7 on the top times the 4 is going to be giving us 28. Okay? So I'll just show that on the next page. Okay. So we changed the number 4, and here's how we did it. So again, we're multiplying. We could write 4 over 1 if you wanted, and then you're writing 7 on the bottom. It becomes more obvious that you're writing 7 times 1 equals 7, right? But we multiply the top, 7 times the 4, we get 28, so 28 over 7, okay? So that's the number 4. Okay, maybe just keep that guy there for now. So the number 4 is 28 over 7. Then we want to change this, all right, here. All right, so okay, so then we want to change the other fraction, right? We want to change. All right, Logan, can you just hold off on that for now, please? Okay? Thanks. So then we want to change the 2 3/7 into a fraction that has 7 on the bottom, right? And remember the way we do that, we multiply the 2 times the 7, that gives us 14. We add the 3, and that gives us 17. Okay, so 2 and 3/7 is 17 over 7. So now we do the subtracting of the two fractions, 28 over 7 minus 17 over 7. Oh, is that someone else? All right. I didn't know who that was, actually. Okay. Well, you know what? I think we are done. All right. Yeah, sorry, I just didn't know who that was, and it was just getting a little distracting here, guys, okay? So, so that's how we do that one there, 4 minus 2 and 3/7. And so yeah, please check out this stuff. You know, have a look over these questions that we did, and you know, all the questions that we did earlier. Oh, we lost somebody. Oh, he's back. Okay, so yeah, guys, please check over these questions that we did earlier. If you practice these questions, I can guarantee you'll do well in the test on Wednesday. Okay? All right, well, thanks a lot for coming, guys. I learned a lot today about pizzas and the fact that Logan likes pizzas, and I learned about some, you know, projects people have done and stuff like that. So, cool stuff. Yeah, I have not met too many people who don't like pizza. All right, well, take care, guys, and have an awesome day. All right, bye for now.